All right, last time we looked at how to find a maximum or a minimum over an interval, but now we're going to talk about finding a maximum and minimum and other information about the entire function just from the first derivative. So let's look at a graph to see what the derivative is telling us and give us a visual of that. So first off, on this graph, we have 3 points of interest here. I've got a minimum down here. I've got a maximum happening up here, and then I have another minimum happening down here. Now, you'll notice that this minimum, since the rest of the graph goes up from here, this minimum is the lowest point of the entire graph. So this is the absolute minimum of the graph. But these other two, this maximum, this is not the absolute maximum. This is a relative or local maximum, local minimum. It's the smallest point in this area, but it's not the lowest the graph ever gets. This is not the highest the graph ever gets. This doesn't have an absolute maximum because it goes off to infinity. So this has an absolute min, but not an absolute max. But let's talk about what is happening at these points, because two different things are happening with the slopes. Because that's what derivative tells us about. Derivative tells us about slope. First off, our derivative here at these points ends up being a horizontal tangent. So if I look at that point and draw the tangent line would be horizontal. So that means that a max or min, horizontal tangent, that means a max or min has to be at a critical point. Which, remember, just means that the derivative is 0 or does not exist. Usually 0. So we're going to look for our critical points. And another thing that's happening is, let's look at the place surrounding one of these points. So let's go to that absolute minimum. Let's go to that absolute minimum and see what is happening at the slope around those points. So if I zoom into this absolute minimum, what you'll see is that my slope is changing. So it hits that horizontal tangent, but before it, the slope was decreasing. It was going down from left to right. So a minimum went from the slope going down to the slope then changing to go up, which should make sense for a minimum, right? It needs to dip down to hit the minimum, and then to keep it from going lower, it needs to rise back up. So from left to right, now it's going from decreasing to increasing. And if we're looking at the derivative, this means that f prime goes from negative to positive. Right? Because negative derivative means a negative slope, means we're going down. For a max, well, it's going to go the other direction. F prime would need to change from positive to negative. So I can see that if I go zoom over here to my maximum and see that it starts by increasing and then it hits my maximum horizontal tangent, and then it goes to decreasing again. So what is happening is that, in general, I find my critical points. This will be step 1. We're going to find our critical points. And then step 2, we're going to figure out whether those critical points is from is a minimum or a maximum, or it could be neither. Neither means that that f prime does not change sign. Which could happen. If you think of like a cubic function, some of those functions go up, they hit this horizontal tangent, and then instead of dipping down at all, it just continues going up. If we're increasing and then we hit that horizontal tangent and then we keep increasing, then we don't have a max or min. And so we could have neither. That's why we need to check the signs around our critical point. So that's what we're going to do. We're going to figure out where our critical points are, and then we're going to check the sign of the derivative around those critical points. So let's look at a basic example to see what that looks like, and we'll practice this more in class tomorrow. Right? Y equals 2x squared minus 8x plus 9. So right away, you should know what this graph looks like. Or have a rough idea of what this graph looks like. You should know the y-intercept's at 0, 9. You should know that this is a parabola. And judging from the fact that the 2 is positive there, then you should know that this parabola is going to open up. Well, if it's a parabola that opens up, then that means that we're probably going to be looking at a minimum at this vertex. And so let's follow our steps. Let's take our derivative. Derivative of 2x squared is going to be 4x to the first minus derivative of 8x is 8. And so we want to know when this is 0. Well, that's easy. We just add 8 to both sides. And then we divide by 4. And so x equals 2. And notice that this point is at negative b over 2a. That's what we said the formula for the vertex was all the way back in Algebra 2. And hopefully it should make sense that that happens, because our derivative means that the 2 is going to hop down in front and get multiplied. That's where the 2a comes from. And then to get to solving it and setting it equal to 0, then we take the opposite sign of our coefficient for b. Instead of subtracting 8, we added 8. So the opposite of b over 2a. Because then we divided by the 4. So that's how we know that vertex is always going to be at negative b over 2a. So at x equals 2. And what we're going to do is we're going to make what's called a sign chart. And we're going to put any critical points we have on this sign chart. We're going to write out our domain. On the left, we're going to put negative infinity and positive infinity for this one, because that's our domain. And so we're going to take any point to the left of 2 and any point to the right of 2 and see if our sign changes. Remember, we're looking for the sign to change. So we have to the left of 2, well, let's use 0. 0 is an easy point to use. Usually we want to use 0. That's an easy point to plug in. So 4 times 0 minus 8, that's going to be a negative 8. So any point to the left of 2 is going to end up being negative. If I plug in points to the right of 2, so let's use 3. 4 times 3 is 12 minus 8. Well, that's positive. And anything to the right of 2. If I pick 10, that's going to be 40 minus 8, still positive. We're just interested in the sign. You don't need to calculate out actual numbers. Whether it's positive or negative is good enough. So f prime changes from negative to positive, that means, well, if it's changing from negative to positive, that means my slope was going down and then it was going up. That means we have to have a minimum at 2. If I plug in 2 here, that's going to be 2 times 2 squared minus 8 times 2 plus 9. 1. So 2, 1 is our minimum. And if we want to be more specific, that is the absolute minimum. That's the smallest that graph gets. Absolute minimum. So looking ahead, we can also get rules for increasing and decreasing. And figuring out mins and maxes and increasing or decreasing, this is the idea behind the first derivative test. Is based on the first derivative, we can determine where there's maxes and mins. We can determine where the function is increasing or decreasing. Function's increasing whenever f prime is positive. And so that's going to be from 2 to positive infinity here. We're decreasing whenever f prime is negative. Because remember, f prime being negative means we have a negative slope. So that's going to be negative infinity to positive 2. So we are decreasing up to 2, and then at 2 we hit our minimum and then start increasing. That's the information we can get from this derivative. So that's our first example. And again, the ideas are that first derivative is going to tell us slope. And so based on what those slopes are, at what points, we can determine where's our maxima, where's our minima, where are we increasing, where are we decreasing. And so that's what we're going to start to look at with these examples going forward here. So we'll look at some more of those tomorrow. I will see you then. Have a good day.